Okay, welcome back sa air conditioning and ventilation system. Tuloy tayo sa ating pinapag-aralan na psychrometric processes. Ang ating aralin ngayon ay sensible cooling. Okay, ito na yung pagpapalamig, sensible. Sabi rito, the cooling of air without any change in its specific humidity. Yung humidity natin sa psychrometric chart, ito siya. Itong horizontal na to papunta rito, yung value niya na dito sa psychrometric chart, may value yan dyan. Okay, so kung mapapansin mo, straight line lang yung 1 mo, yung 0.1 and 0.2 and 0.3 actually is the same. Pero ang ating inaaral dito is yung air na pumasok dito at 0.1 at lumabas dito sa 0.2. Kaya pinakita natin dito yung W1 or specific humidity at 1 is equal to specific humidity at 2. Kasi nga, we emphasize that this is sensible cooling. Okay? So, let air at a temperature of TD1, ito na nga, TD1, passes over a cooling coil of temperature na TD3 as shown in figure 16, 17A. Ito. So may pipe, may cooling coil pipe ka. Actually, tawag lang dyan, cooling coil. Pero pipe yan. Okay. Sa loob niyan, merong refrigerant. Yung refrigerant mo, depende. Basta refrigerant, it could be R134A. It could be any modern refrigerant. Kasi ang dating mga refrigerant, yung R22, hindi na ginagamit yun dahil harmful sa environment. So, pwede yun, So, ganyan ang sistema. Okay, and tapos, it may be noted that the temperature of air leaving the cooling coil TD2 will be more than TD3. Yeah, more than TD3. The process of sensible cooling on the psychrometric chart is shown in horizontal 1-2 extending from right to the left as shown in figure 16.17b. Ito na nga. So from process 1, from point 1 to point 2. The point 3, itong point 3 na to, ayan siya, represents the surface of the cooling coil. Surface yan ng cooling coil. Okay? So, ito siya. So, ang point 1 mo is defined by temperature, dry bulb temperature 1 and RH1. Then, you have a point. Pwede mo project para makuha mo yung enthalpy 1. Tapos, meron kang temperature 2, dry bulb temperature 2, and then you must have an RH at that point, RH2. You got a point 2 here. Yan. You can project it to get your H2. Since na sensible yan, straight line lang, if you have TD3, in this case we have, and then wala ka ng RH dyan, that can be defined by your, pwedeng ma-define to na itong specific humidity, di ba? May intersection ka rin naman dyan Actually, yan nga yung pwedeng gamitin from the very beginning. Meron kang dry bulb temperature, meron kang specific humidity, you also define a point kung saan makukuha mo rin itong RH at makukuha mo rin itong enthalpy at iba pang mga properties kagaya ng wet bulb, no? So on and so forth, maging specific volume. If you have two properties that defines your state, yung kalagayan ng air. Okay? So, move further. Ayan. So, ang sinasabi niya rito, na yung heat rejection by air during sensible cooling may be obtained from the psychrometric chart by the enthalpy difference yung H1, mataas yung H1 mo, minus H2 as shown in the figure 16.17b. Totoo naman, kitang-kita naman doon yun. So, napakadali lang kapag kakabisado na natin yung psychrometric terms at saka psychrometric relations, yung mga formula, and then we are now proceeding to the psychrometric processes. Okay, let's move forward. It may be noted that the specific humidity during the sensible cooling remains constant. So, na-note na rin naman natin yan, no? Kanina. And we are just repeating it. I'm just repeating it so that it will, drive deep to our senses na talaga equal yung specific humidity or moisture content kapag sensible cooling at saka sensible heating. So in this case, sensible cooling, equal pa rin yan. Okay? So the dry bulb temperature reduces from TD1 to TD2. So nag-reduce siya, and the relative humidity from 1 to 2 as shown in the figure. The amount of heat rejected during the sensible cooling may be obtained from the relation. So, obtain na natin. Ito siya. Okay? So, yun ang sinabi natin kanina. We have, because we have 2 points, so we're able to locate H1 in the psychrometric chart. We're able to locate also itong H2. Okay? So, yung H1 mo is equal to specific heat, constant pressure ng air, tapos yung difference nitong temperature na to, dry bulb 1 at saka dry bulb temperature 2, plus itong H2, which is equal to W times Cp okay, Cp S ba yan? Okay. Wait okay, CPS times the times alin yung kanilang delta change of temperature, no? So, same as doon sa heat o sa sensible heating, di ba? So, kakaroon na naman tayo ng simplification dito. Nandito pa rin tong term na ito. CPA plus WCPS. Ang tawag dyan, humid specific heat, CPM. And that is equal to 1.022 kilojoule per kilogram. Sa ibang system, kilocalorie ito, yung heat. Okay, kaya baka mamaya, bigyan kayo, aralin nyo yung dito, SI lang tayo. Pero it could be BTU per hour. Okay, so we will try to give you problems also in other unit. So, aralin nyo class yung ibang unit system nitong heat. So, there will be BTU, there will be calorie, in here, kilojoule tayo. Okay? So, yung heat rejected in small q, okay, is equal to 1.022, tawag natin dyan, humid specific heat, times delta T. Diba? Kabaliktaran lang ng heating, sensible heating. Parang kabaliktaran lang. Okay? So, tuloy lang natin. Sabi rito, for air conditioning purposes, the heat per minute is given as, yung sensible heat per minute daw is given as SH, mass ng air, CP ng air times delta T. Pwede rin namang in terms of specific volume. Rate daw yan. Rate of dry air flowing. So, flow rate ito. Itong small v. Tapos, in terms of density, in terms of humid specific heat, no? Yung CPM at saka delta T. Okay? Take note na yung mass mo is equal to specific the specific volume, hindi yan specific volume, kundi volume flow rate times the density. Tapos ito, delta T mo, sinasabi niya lang, ito yung bagong term for air conditioning. Ang tawag dyan, sensible heat. Okay, sensible heat. Ano yung sensible heat? Pwedeng yung heat nga, sensible. Pwedeng generalized terms, kumbaga. That stands for sensible heat. Okay? Tapos, substituting the value of density and CPM sa above expression, dito sa expression na ito. Ayan. Ito na siya. SH or sensible heat is equal to ito, V times 1.2 times 1.022 times delta T. Na-reduce na siya ng, pwede rin siyang equal sa 1.2264 times volume flow rate times delta T in kilojoule per minute. Okay? At pwede pa rin natin express further sa ganitong terms value. Kilowatt na to. Okay, yung sensible heat or SH could be expressed Okay? Into 0.02044 times volume flow rate. Tingnan nyo yung V na yan. Okay, malito. Cubic meter per minute yan. Times delta T. So, dalawa na lang yan, no? Delta T at saka volume flow rate. Note. May note ka rito. 1. For sensible cooling, the cooling coil may be a refrigerant, cooling water, kapag chilled water system ka. Cold gas flowing through it, pwedeng ganun. Okay, sa B, or number 2, na note niya, the sensible cooling can be done only up to the dew point temperature. Sa DP lang yan. As shown in figure 16B, the cooling below this temperature will result in condensation of the moisture. Okay? So, yung sensible cooling daw is up to dew point temperature. Okay? Okay, andyan lang muna tayo sa sensible cooling. So, that's a good note for us. Okay? Balikan na natin ang sabi niya doon sa note niya. Dito sa figure. Gusto ko lang pakita. And I want to emphasize it again. Na yung cooling mo up to dito lang. Okay? To here. Ano yan? Yan yung dew point temperature. Sabi niya, pag binaba mo pa dyan, mag-umpisa na mag-condensate yung water vapor na nasa moist air or na nasa dry air. Okay?